Hello, my name is Mia, and this is my Physics 2212 Lab 2. So, to introduce, the purpose of this lab was to create a computer model of the charge tapes from the previous lab 1 that we did by modeling them as lines with evenly distributed charges. So the physics concepts used in this lab are Coulomb's law, which is F equals K times Q1, Q2 all over R squared, and Newton's second law, which is F equals mass times acceleration. So for the model, we were using the charged tapes as the experiments from lab 1. We were using the experimental data from that lab and using it within the model. We're showing those charged tapes as the charge evenly distributed across the line, and the force of gravity and the force of the electric field and the electric field due to the charged tapes are all shown within the model. The surroundings of the model, the system of the model is the tape on top, and the tape on the bottom is part of the surroundings. So for our assumptions for this model, charge is evenly distributed over the tape, so the charge is not grouping up on one end or the other. It's evenly distributed. We're also assuming the air resistance is negligible, so when the bottom tape moved up when the top tape moved up due to the bottom tape, we're assuming that air resistance did not have an effect on it. So here's the model that I created. As you can see, the top tape is modeled as the red line, and the bottom tape is modeled as the blue line. The electric field is shown in green here with all these green arrows. The force of the electric field is this white arrow, and the force of gravity is this yellow arrow. So the magnitude of the electric force was found to be 0.0373761, and the magnitude of the gravitational force was found to be the exact same, showing that the charge tapes were in equilibrium when they were moved near each other, and they were not moving at all. So for the questions for the lab, what if you had modeled each of your tapes as a single point charge like in the previous lab? The estimated charge in the previous lab was 0.073, and the line charge model was 0.0373761. So if we had modeled the tapes as point charges, the number of the electric force, number for the electric force would just be less accurate than in the line charge model. And why do these estimates differ? Which value is more likely to be closer to the real value, and why? So these estimates differ because when the charge tape is modeled as a line, the charge is distributed across the whole line rather than one singular point. So it's taking into account the distance that the charge is distributed across, similar to in class where we had to calculate the charge using integrals over a small distance. The model is doing a similar thing where it is using a small distance of the line charge to calculate the force of the electric field, making this number super accurate. And then when the electric field number is calculated as a force, this number is going to be more accurate than the number that was found for the point charge when the tape was modeled as a point charge. So this is my lab. Thank you for watching.